Welcome back to my channel. In this video, we'll discuss the pin details of 8051 microcontroller. It is a 40-pin IC and it is available in dual package. Let us see the pin details of this IC. Out of these 40 pins, 32 pins are bidirectional IO pins. And these IO pins are organized as 4 ports, and the ports are port 0, port 1, port 2 and port 3. Each have 8 lines, that is port 0 have 0 to 7, port 1 1 to 7, port 2 0 to 7 and port 3 0 to 7. So out of 40 pins, 32 pins are IO pins and they are organized as 4 ports and each port consists of 8 pins. So remaining we have 8 pins. So for any IC, we need a power supply. First let us see the power supply pins. There is 2 pins, one is VCC and another one is VSS. VCC, it will be connected to plus 5 volt, that is the positive power supply. This IC is operated on plus 5 volt VCC, and next VSS is negative power supply, that is it is connected to ground. Next pin is reset, which is used to reset the microcontroller. And next one is if you want to generate a different clock frequency, we have to connect an external crystal oscillator to this microcontroller. For that, there is 2 pins, that is Cristal 1 and Cristal 2. These 2 pins are to connect the external quartz crystal oscillator into this microcontroller, which will generate the different clock frequency. Out of 8, 2, 3, 4, 5. So 5 pins are over, remaining 3. The 3 pins are called control pins. They are EA, ALE and PSEN. This EA and PSEN is active low output signal and ALE is active high output signal. These 3 are used to access the external program memory. EA, that is external access, and ALE is known as address latch enable. PSEN is known as program store enable. Let us see one by one. First, we will fix the location of all the pins. Major part is ports. Port 0, 1, 2, 3. So start from this right side. So here port 0 and this side port 1. Here in the lower part of IC we have port 2. And in the left side lower part we have port 3. This is the location of ports. Port 0, 1, 2, 3. So from this, in the left hand side we have odd numbered ports, port 1, port 3. And in right side we have even numbered ports, that is port 0 and port 2. Right. And first we will fix the power supply pins. VCC is on 40th pin and just opposite to that VCC at 20th pin we have VSS. Okay. So next that external crystal input, that is XTAL 2 and XTAL 1, Cristal 1 and Cristal 2. So by means of these 2 pins, the external quartz crystal is connected to this microcontroller, and this Cristal 2 pin is a bidirectional pin through which your microcontroller output the clock frequency to the peripheral device. So it is a bidirectional one, it is a input pin. So next we will fix port 0. Port 0 has 8 pins, that is port 0, 0 to 7. So you have to start from 39th pin. This is port 0, 0th pin, first pin. It is a bidirectional pin. So it acts as a IO lines, that is input output pin. Other than this, it has some additional functions. It will act as a multiplexed address and data line. So it is called as AD. In port 0, your lower bytes of address and data lines are multiplexed. So these lines are also called as AD0 to AD7. So next one, P1. P1, start from here, P1. Here are bidirectional I/O pins. And this port 1 is a dedicated I/O pin. It has no other special functions. And next one is port 2. So you have to start from the last pin, that is 21. So you have to start from here. So this is port 2. 2 is act as a I/O line, and also it has an additional function, that is it carry the higher order address. So it is A8, A9, so port 2 is a I/O pin, and also it carries the higher order bytes of address lines. So next one is port 3. So before that, here after this port 1, we have a reset pin, which is an active high input pin. So reset pin, the function of reset pin is, it is to clear the microcontroller. Otherwise it is to reset or clear all the registers of microcontroller except program counter. And this reset pin is a active high pin, and this microcontroller is reset only if this reset pin is high for at least 2 machine cycles. If this reset pin is high for at least 2 machine cycles, then the microcontroller will reset all the contents of this register. The next P3, you have to start from this pin. This is P3. P3 is a I/O port, which can act as an input line or output line, and it also has a special functions, and that special functions are, first P30 is act as a RXT, TXT. Next one is interrupt 0. The next one interrupt 1. This one is T0, this is T1, and this is write, and this is read. Okay. So RXT, this is used for serial communication. Through this pin, your microcontroller receives the data from the peripheral, and TXT, it is to transmit the data from the microcontroller to the peripherals. And in microcontroller, there is 5 interrupts, 3 are internal interrupts and 2 are external interrupts. That external interrupts are given through these lines P32 and P33. So P32 external interrupt 0 and P33 is external interrupt 1. And your microcontroller has 2 timers, timer 0 and timer 1. The external input to this timer is given through this pin P34 and P35. This is for timer 0 and this is for timer 1. Then last 2 pins are indicate that your microcontroller whether read the data from the memory or write the data into the memory. If this is enabled, then the microcontroller write the data into the memory, that is external memory. If this is enabled, then the microcontroller read the content from the external memory. These 2 are active low inputs. So the remaining 3 pins are EA. The next one is ALE. The last one is program store enable. Here this EA pin and program store enable pin is active low pin. This EA is to indicate whether the program is in external memory or internal memory. If this EA pin is low, that is 0, EA pin is 0, then the memory is external memory. We are using the external memory. that is your program code is stored in the external memory. If AA pin is 1, then our program is stored in the internal memory, and your 8051 has 4 kilobytes of internal read-only memory that will be used as a program memory. For this case, EA bar is equal to 1. So ALE pin which is used when we access the external program memory. So we have to indicate the memory location. For that you need an address. So when ALE is equal to 1, it is an active high output. When ALE is equal to 1, then this multiplexed address data lines are demultiplexed and we get a address from this lines. So to demultiplex the address from this multiplex line, we need ALE. If ALE is 1, then the address line is demultiplexed from this port 0. And last one is program store enable. It is an active low output pin. It is used when we use the external program memory to store the code. If the microcontroller want to read the code from the external memory, we need this that is program store enable output pin. If your program code is stored in the external room, means this program store enable pin is connected with output enable pin of the external room. So if you want to fetch the data from this room, 0 is given to program store enable, which will enable the external program memory. So the microcontroller can fetch the data from this external read-only memory. So to read the code from the external memory, we need program store enable. Because when it is 0, it is directly connected to output enable pin of the external read-only memory. So the external read-only memory is enabled. Now the microcontroller is easily access the code from the external memory. That's all about the pins of 8051.